Good day and welcome to the IEEE Computer Society's presentation on How to Leverage Open Source Without Adding Risk by Mark Curphey. This webinar is proudly sponsored by Veracode. My name is Amir and I will be moderating today's presentation. At the end of the presentation, we will have time for questions, and as questions occur to you, please type them into the box provided and press the submit button. You do not need to wait until the end of the presentation. Now, I would like to introduce our speaker for today's webinar. Mark is the VP of Strategy at CA Veracode and is the founder and CEO of SourceClear, a software composition analysis solution designed for DevSecOps, which was acquired by CA Technologies in 2018. In 2001, he founded the Open Web Application Security Project, OWASP, a nonprofit organization known for its top 10 list of the most critical web application security risks. Ladies and gentlemen, Mark Curphey.
Great. Thank you very much, Amir. Good morning, and thank you everyone for joining. Here from San Francisco, a freezing cold summer day in San Francisco. So what we're going to do today is sort of walk through 10 or 12 or so slides, really just framing the space. And then what I'll do is I'll share my desktop and we'll start perusing a bunch of projects so that you can actually see live what the sort of things that we're talking about, the sort of complexity of open source, the state of vulnerabilities in certain projects. We'll use the SourceClear platform because not only, of course, I'm biased, but not only is it the best thing to go leverage that with, it's to hand. And we'll kind of walk through how that works, but we'll avoid making it a sort of product demo for sure. Please ask questions as and when we go through. My experience of these things is the best way of interactive kind of sessions, and we'll queue up the questions and go through that at the end. So the first thing I just want to kind of start off with is really kind of framing this whole thing around open source and security. After what happened with Equifax, which, the biggest data breach in history, which was as a result of a company that really was not patching a set of vulnerable open source, this whole space has of course got a lot of media attention. But it really started back with Shellshock, which was this OpenSSL library that was embedded everywhere. And this was really the first time that people started to understand that the threat landscape has changed. Instead of everyone creating individual pieces of software, all of a sudden we were starting to place reusable pieces of software into devices, into software that was being replicated everywhere. And so, instead of this whole kind of notion of reusable software, we suddenly had reusable vulnerabilities. And the attack surface changed, that the forward-thinking attackers suddenly realized we're in a similar type of condition that happened when viruses started propagating in the 90s. I can create one vulnerability, and I now have a distribution mechanism to do this. And part of that is this massive rise of open source software. So Mark Andreessen, who is now a venture capitalist here in Silicon Valley, was the guy who created Netscape, wrote the first Netscape browser, has a very famous phrase, and that phrase was that software is eating the world. And what he means by that is that, traditional financial services companies, car companies are now all becoming software companies, and software is the thing that is empowering all of these massive business changes. There's certainly no doubt that is absolutely happening. If you go to code.gov, under the Obama administration, President Obama made a executive order.
Excuse me, Mark.
20%. Yes.
We aren't able to see your slide, sir. I think everyone has a blank screen.
Oh, I'm extremely sorry. Is that corrected then?
It's currently buffering. There we go.
Okay, great. So this was the slide of software eating the world. And the slide that is up should show the NSA logo in the background. And under the Obama administration, President Obama created an executive order that said that 20% of the U.S. government code must be open sourced. And if you go to code.gov, you will see a wide variety of things there, from voting software, software where you can register to vote, through to things like Apache NiFi, which was a routing system for intelligence information, as well as a whole host of other things. So there's no doubt that open source is absolutely pervasive. In the commercial space, we often look at iconic brands now, and most of these iconic brands have been built on the back of open source. So we think about Facebook. Facebook is predominantly built on open source code. That doesn't mean to say that Facebook itself is open source, but all of the pieces that allow Facebook to build their service are open sourced, or they produce a set of pieces that they open source themselves. The React framework is one of the most famous ones that have come out of Facebook, which is a front-end framework which allows you both to build web applications but also native mobile applications. Google, when we think about it, Chromium is a core part. Now Kubernetes in the DevOps space. And so when we think about, really software is eating the world, I would really say that it's open source that is eating the world. When we think now about, Teslas, Tesla is ultimately based on a Linux kernel which powers that autonomous vehicle. So the pervasiveness of open source, really hasn't caught anyone by surprise, but a lot of people don't understand quite how pervasive it is. And I'm still surprised sometimes when we go talk to CIOs of large financial services companies, for instance, and you ask them, how much open source do you have? And you're typically faced with a binary response, not a lot or everything. And even the people that say not a lot really don't understand how their software development inside of their engineering teams has changed to the point where developers really go and embrace open source first. If you're building an application today, you really wouldn't dream of figuring out how to build it from the ground up with your own code. You take a framework and you figure out how to go do it, and we'll kind of walk through how that happens and the security implications of that in a second. The amount of libraries and the amount of choice that's out there for the developers is absolutely phenomenal. This is a screen capture from a website called Module Counts. Module Counts itself is open source. You can figure out how to go collect these statistics if you go to GitHub. And what you're seeing on those lines is interesting when you look through it. What we've seen traditionally was that Java, which still powers the majority of enterprise applications, it's still behind Android as an example, was really held up as the poster child for open source distribution. A system called Maven Central, which acted as a directory service where you could go find these libraries and then go pull them into your projects, and we'll talk about how that happens in a second. And you'll see that yellow line there, and you'll see as absolute growth. But what stands out on this is NPM. So NPM stands for the Node Package Manager, and this is the way that you distribute JavaScript. And what you see there is the line that it's almost like getting into a hockey stick growth curve. Way it just completely surpasses whatever happened with Java. And that is the modern approach. If you look at most people that are building modern front ends, and if we go back to Facebook with their React framework, or Google with their Angular framework, libraries that plug into that ecosystem are distributed through NPM. And you'll see in a short period of time, we now have way more libraries in the NPM ecosystem than we ever did with the Java ecosystem. There is a lot of that you can plug underneath the hood. We've actually been doing a lot of research, and it turns out that the vast majority of NPM libraries are actually released on a Monday. The vast majority of Java libraries are released during the week. We still don't know whether that is the fact that most JavaScript developers, build their libraries and their ecosystems over the weekend as hobbies and release them on the Monday. Java libraries release them during the week. We don't know that that's the case, but we're certainly seeing different patterns that are happening inside of these ecosystems. And if we had plotted the line of Go, and we'll talk about that in a second as one of the big trends that we have to watch for, the Go language is now taking off like wildfire, particularly here in Silicon Valley. It's a high-performance language that allows us to build applications and somewhat abstracted and agnostic from the deployment environment. Go is increasing even faster than NPM. And so we actually had our data scientist look at this, and he did some somewhat linear math. So he basically took the rate of libraries that are being released, and then we looked at the trends that are happening underneath that to predict how many libraries we think we'll have. And so one of the trends that we've been seeing in the Java ecosystem is that libraries used to be released about 4 times a year on average. Now they're being released about 6 times a year on average. So then we can do some linear math and say, great, over the next period, what do we think that frequency is going to be? We've also seen libraries that are being split up. So one library may become 10 smaller libraries, and that particularly happens in the NPM, the node ecosystem. And if we extrapolated that into simple linear math, and again, I think it's easy to pick a hole in, but it's directionally correct. We're approaching the phase that within the next decade, we'll probably have about 500 million libraries that are out there. And this has a very, very big implication. If we think about it, people can now copy a library very quickly and create a brand new library. If they copied a library that was vulnerable, the next library then inherits the same problems. We wind up with one library that is using another one which may become vulnerable. And so we kind of think about this as essentially like DNA. And what's happening is this DNA, the code, is morphing, and it's becoming such a vast ecosystem that the choice in understanding what you have is incredibly hard. And that's really what this whole notion of software composition analysis is aiming to solve. And we'll kind of get down to a couple of simple set of questions that you now have to ask in a second. I think everyone knows, and I think we're targeting the developer audience today, but it's just worth reiterating how open source gets consumed inside of an application, because I think a lot of people and particularly people that aren't developers often have a misnomer. Are we talking about the Apache HTTP server, or are we talking about Linux here? When a developer decides to go build an application today, the first thing they typically wind up doing is choosing a framework to go use. So if they're a Java developer, they may choose Spring, they may choose Apache Struts, and we can go look at Struts in a second. They then write their custom application on top of that. And then, if they want to go, use a set of functionality, they typically then will go to one of the open source library distributions or one of the other mini frameworks, as it were, and go and add that into their application. Because what they don't want to do is they want to focus on building features and functionality that differentiate themselves versus building the same thing over and over again. There is little point in building, great user management features today. Other people have solved that problem, but there may be great, ability to go build the function that your application does. When your application is complete today, it can be as much as 95% open source code, i.e. code that came from someone else. And we have statistics even of very large network manufacturing companies that 75% of their entire code base was not created by them in their products. And those statistics are incredible, because when we think about the way that we used to apply application security, we would spend our time educating our own developers. We would do threat models on our application. We would apply, a code analysis to the code that we write. But if the vast majority of code is coming in and doesn't undergo those rigors and those controls, all of a sudden we have a massive problem. And that is kind of fundamental to the core of what we have with the problem with open source security today. That problem has also been compounded in that when you go run these package managers, and so in the open source world, NPM, Yarn, which is now the sort of super popular package manager, which was released out of Facebook for JavaScript, or Maven or Gradle, which is now sort of taking over from Maven, I think, in the Java world, and a whole host of these package managers. They manage the complexity of this open source on behalf of the developer. So it's not reasonable, of course, to expect a developer to track all of his libraries, figure out which versions will work together. So the package managers take care of that on behalf of the developer and make life very simple. Part of the reason why open source has taken off is that it is very simple to go use and manage this very complex ecosystem. But the reality is that when these package managers do their work, they make a lot of decisions that have a very big impact on security behind the scenes. So to give you an example, if you put in a particular version range of libraries that may work for you for a particular library, the package manager itself will make the decision as to which version will satisfy the condition. And among that version range, there may be a set of vulnerable libraries. And so you may satisfy the condition that you specified in your code, but in doing so may pull in a vulnerable library. And so there's a lot of other kind of edge case conditions. These package managers optimize around network performance. They may choose that a library that is sat in your local cache on your local build system satisfies the dependency condition even though it may have a vulnerable library. And we are yet to the point where these package managers that make these important decisions allow you to also specify the level of trust, the level of security confidence that you have in that. The NPM ecosystem is moving towards that and should be absolutely a huge pat on the back for doing that. But the others are yet to do that. So package managers have a huge implication. Not only that, the way that these open source ecosystems work is it's like what we often refer to as a Russian nested doll syndrome. So typically you will specify a set of libraries in your open source code. Those libraries themselves may then have specified another set of libraries. So it's kind of like we decide to have a webinar. 20 people get invited to the webinar. 20 people invite another 20 people, who then invite another 20 people. And before we know it, we have 400 people on a webinar. That causes a lot of challenges. If anyone has ever seen the movie Ferris Bueller's Day Off, that is exactly what happened to Ferris Bueller when he has a party. He has a party, and all of a sudden, the people that he invites invite a whole bunch of other people, and before you know it, someone trashes his parents' house. This is the same scenario that we're faced with open source. And we'll pull up an example towards the end. We'll use the code from vote.gov, which was from one of the examples that we had earlier, so some of the code that was open sourced as part of the code.gov initiative. That application was a JavaScript application built with Node. It specified 19 libraries, so the developer originally decided that he needed to use 19 libraries. But by the time you actually build that application, it uses nearly 600. And so this problem of pulling in all of these different libraries, we refer to those libraries as direct libraries, the ones that the developer specifically wanted, and then transitive libraries or indirect libraries as the ones that get pulled in. And of course, the bad guys understand this. They understand that there are libraries that are deep nested in this ecosystem that everyone else uses and that they get pulled in behind the scenes. So I think it was about 18 months ago, maybe even 2 years ago, we had a significant problem with NPM. The story goes that the developer of a particular library, and the library was called LeftPad, also developed a library called Kik, K-I-K. And the library Kik was subject to a legal claim from the people who make the Kik instant messenger, who said you can't use our name. And so he decided, great, I'm just going to remove all of my libraries. I'm not going to deal with this problem. His other library called LeftPad was a very small library. In fact, it was 11 lines of code, and it padded characters left. But it turned out that the LeftPad library had been used by something called the Express framework. The Express framework was the most popular server-side JavaScript framework for building web applications. And as a result of him pulling this thing down, basically everyone's build stopped failing. The package manager could no longer find the LeftPad library and therefore couldn't build the projects. And of course, within minutes and within hours, everyone went into panic. I think there were 250,000 builds that failed in the first hour or so when that library was taken down. The bad guys quickly realized, though, that what they could do is hijack that library. And then every time everyone ran the build, they would actually pull in their malicious version of LeftPad. And the NPM guys, to their credit, figured out what was going on and quickly stopped this happening. But we've seen a number of cases now where the bad guys are poisoning the supply chain. They understand that everyone automatically pulls in these packages with very little scrutiny, and it allows them to have an ecosystem in which they can deliver malicious packages and malicious payloads to millions of developers or millions of build systems. And we've seen that happen in the JavaScript world several times. There have been Node packages that, when ran, have looked for people's SSH keys, looked for people's AWS credentials. We have seen the cases of LeftPad packages being hijacked. We've seen it in the Python ecosystem, where they specifically were attacking big data systems and have every reason to believe, in fact, I know for a fact, those packages exist in other ecosystems as well. And when you think about the way that we distribute that software, it's somewhat analogous to early days of the web. When we used to browse the web, we didn't expect a padlock. We trusted that we were on a domain, and that's where the software came from. And these distribution systems for this open source provide no or very minimal guarantees or assurances, not guarantees, of where the software came from. So to give you an example of that in the JavaScript, in the Java world, Maven Central, if you want to upload a library to Maven, you generate a PGP key. And so that PGP key is supposedly to verify the authenticity and the origin of who created that software. Unfortunately, that PGP key is simply an email address. And so it's very easy to go generate an email address of something that looks like a legitimate developer. A PGP key is perfectly valid. And we have seen cases where people have renamed libraries into, Log4j next generation, and all of a sudden developers, pull these things down. And in fact, we've run experiments with that on all of the ecosystems, and it is somewhat scary to see how people blindly trust these things and simply pull them down. The ecosystem itself, this was a screenshot yesterday from NPM. And that is a visualization, and it is, if you go to that URL, it is fascinating to understand just how complex and interwoven these ecosystems are. And the image, of course, looks like absolute chaos, but it's not. It's a live map between every library and how they are interacted. And you can go and explore it, and it's an absolutely amazing thing to go do. But the story that it really tells you is that control over what is in your code has gone from you. So from the fact that you wrote this code, you can choose to all of the security choices. But that has now gone to the developer tools, package managers, build systems. It's moved to open source code, other code that your application is using or you're including inside of your application, and the third-party developers that create that code. And unfortunately, we're living in a world where we would all love to trust everything that happens on the internet, but it's unreasonable. And there are malicious third-party developers, including ones from state-sponsored governments, that are creating open source code or putting bad open source code into the ecosystem. So what's also happened around this challenge is that the world that we lived before DevOps, we had to really think about security from the perspective of, am I introducing vulnerabilities into the code that I'm creating? And that was the world where the vast majority of code was custom code. As we talked about, 75%, 90% of the code was custom code, and a small portion was open source code. But the way to think about the space today is that in the new world that we live in, so I refer to it as after DevOps, the post-DevOps era, which is the era that we're living in today, where the vast majority of code is open source code. We simply have to frame the problem in a different way. We have to understand at all times, what open source am I actually using? So at any point in time, we need to understand what is being included. And that's not necessarily what is being specified in my source code. It is what is being included when I go run the build, i.e. what is being pulled in. And that specification of exactly what is being pulled in can be different at any point in time. And we need to understand that. The second problem that we need to understand is, where did it come from? And so by that it means, did it come from a trusted source? i.e. did I pull it from something that I trust? And do I know who the developers are, and should I trust them? The third question we have to ask is, what does it do? I think I'm including a logging library, but am I accidentally including a piece of malware that is claiming to be a logging library? And the fourth problem, of course, is what vulnerabilities are present in the code when I understand what I'm doing, so I can make a set of informed decisions around, is that okay? Am I using it in a way that I believe is vulnerable? And each of these questions are incredibly easy to ask, but very complex to answer, because of the complexity of the open source ecosystem and the complexity and sophistication of the package management tools. So again, to reinforce the point, what open source am I using? You can't simply grep through the build file. You have to understand exactly what is being pulled in at build time. A lot of the languages, so for example, Ruby gems has a lock file, and the idea is that lock file specifies all of the libraries that would be pulled in. But that lock file is often out of sync that if you actually run bundle install. The same with Node, they have lock files, and you may run the build. And so what happens in the DevOps world is we have these convenient systems that allows all of the developers to share a common set of libraries, but often in a DevOps build pipeline, that common set of libraries is thrown away, and we go rebuild from scratch. And particularly with the amount of compute power that we have and the amount of bandwidth, we don't have to optimize things in the way that we used to in the old days of makefiles and other things. The question of what does the code do also becomes incredibly hard to do. And it's certainly true of the argument that it's open source code, therefore I can look at the code, is fantastic. But the reality is that the amount of code that is being pulled in, it's unreasonable to expect anyone to look at the code, and particularly anyone to look at code of all the new libraries that are changing. We have seen attacks where developers, malicious developers, have built up very large followings, and they've done it with essentially libraries that were legitimate. They had a legitimate set of functionality. And then either the developers' accounts were taken over on the upstream distribution system, or there has been some cases where the developers have actually sold their account. The libraries upstream then have been changed to do something malicious, and all of a sudden everyone who then goes run the builds inherits the malicious library. So understanding what it does, again, is a case in the DevOps world where we now have to understand what that thing does at any point in time where the build happens. And so the reality also today is that we're living in a world where we have to think about vulnerabilities in a set of classes such as this. So the first type of vulnerability that we have to think about is, what am I inheriting? I may choose to use 10 libraries in my application. So I may specify those in the POM file in Java or the package.json file in NPM. But there's a whole set of other, and those 10 libraries, I may provide the scrutiny to figure out that those libraries don't have any vulnerabilities, and I'm using the latest versions of those. But those libraries themselves may go pull in another 100 or 200 libraries, and therefore you wind up inheriting a set of vulnerabilities. So inherited vulnerabilities become a big issue. We also have up here this notion of disclosed and half days. So historically, there was a system which was created, and it's called the National Vulnerability Database. And this thing was essentially funded by the Department of Homeland Security, and it was really defined to be the authoritative source of truth about vulnerabilities. The NVD was really driven by MITRE, who are funded by DHS to produce this authoritative source of vulnerabilities. But when that scheme was created, it was really created in an era where we were living designed for Microsoft Windows and Internet Explorer, where we could follow responsible disclosure. We could spend 6 weeks finding a vulnerability, pushing the information out, and we could trust that as a source of truth. The reality these days is that the pace of DevOps moves that most developers, when they find a vulnerability, do not report it to the NVD. They find it. They often just fix it in situ and then just recommit the code. Sometimes they fix it in situ and re-release a new version and tell people about it. Sometimes they update it in the change log. But what they rarely do is go back to essentially a government-backed system and wait 6 weeks to be issued with a number. And so we're faced with this world where the traditional ways of us finding where the vulnerabilities were essentially syncing to this authoritative source of data is no longer true. And if you know where to go look, if you look in the commit logs of upstream developer projects, if you look in the Jira tickets, if you pass through the change logs, you can often see these things in plain sight. So for example, there was another recent vulnerability in struts, which caused a lot of problems. I think it was publicly released on August the 22nd. But actually, if you knew where to go look, it was in the commit log on June 21st, because the developer found it and fixed it and put, hey, this is fixing this issue. I don't think he mentioned anything in the commit logs, but if you saw the code that was being changed, it really didn't take a sophisticated security researcher to understand the vulnerability that was being fixed. That then left a window between June 21st and August 22nd for the people that are watching struts to understand that that vulnerability exists, and it was a remote code execution vulnerability for it to go be exploited. So we're living in a fundamentally different world to the one that we lived in before. We're also living in this world where Stack Exchange, and I'm sure most people on this webinar are familiar and use Stack Exchange, and it's just an amazing resource. But there's no shortage of opinions, and there's no shortage of people who tell you how to go fix things. I can tell you, if you go look at a lot of security solutions, particularly in some of the modern languages, they are insecure. They are not good practice. But people copy and paste that code and put it into their own libraries. we've run a study. Vanessa here is one of our great security researchers. Looked at Ruby gems, and she found a piece of vulnerable code. Essentially, it was very, very simple. It was someone using a vulnerable version of the jQuery library, and they'd hard-coded it into Ruby gems. And we said, wow, wouldn't it be fascinating to figure out how many other Ruby gems do exactly the same thing? Sure enough, 300 or 400 others that also had the same vulnerability. So we see this notion of copy and paste vulnerabilities being put across the ecosystem and pulled out. So we're living in this world now where these types of things exist. And the world that we're likely to move into is that we are likely to see ransomware, adware pushed up into the open source ecosystem as well. So we've proven out the fact that this is the case, that the same conditions occur for SQL Slammer on Windows, where you have the ability for a person to push a vulnerability upstream and have it propagate onto many, many other downstream components. So we've written some proof of concepts for Spring, for NPM, that basically, and for Ruby, I think we've got it working on all the major ecosystems, that all I need to do is to get a developer to install a library. And once they've installed that library, I can figure out exactly what their database connectivity is. I can essentially encrypt the database, throw it away, drop up a ransomware page, and the next time they go up to their website, they're faced with, send me X amount of Bitcoin. I don't know how many Bitcoin you have to send, probably like 10 million Bitcoin for it to be worth it these days versus the 0.1 a couple of weeks ago. But we're able to do that. And so what we are likely to see as well is that the open source security problem is going to move from pure vulnerabilities that can be exploited one by one into people pushing ransomware. And the difference is going to be is that from a ransomware perspective, what we saw in the first generation of ransomware is it was targeting desktops, right? So we saw the WannaCry type thing, and they were, ransomwaring individuals. But what we see with open source software, particularly from when the developers are used as the mule, the drug mule to go push these bad things, it's going right into the heart of business. So can you imagine if someone ransomwared an online bank that was built with Java? I can imagine that online bank, that's a much higher value target and a much higher profile target. And so again, the attack surface and the threat landscape is changing with open source and the way that developers are consuming it. And so this whole notion of Equifax, Shellshock, Heartbleed, we have a fairly high degree of confidence that this really is the opening salvo in a big breed of major attacks that are going to happen. And the more and more open source is embedded into voting systems, cars, financial services, that's how the problem is going to become important to solve. The good news is that there are systems to go solve this, and we've now got to the point where I think it's kind of widely understood that you generally, in your application security program, you have to have a set of things. One of those things is static analysis, so SAST, which scans your custom code and makes sure that you're not introducing vulnerabilities such as SQL injection, cross-site scripting, etc. And now software composition analysis to make sure that you're not consuming poor open source code. And generally those two things work in unison together. And obviously here at Veracode, we've now integrating the SourceClear technology to the Veracode platform to have the best of breed of how those two things work. And the good news as well is that traditionally security in a non-DevOps world was a kind of waterfall approach. You wanted to go deploy into production, you would get a final release review that would take you some time. We are now living in the world of DevOps where we're creating automated pipelines. And the great news is that for the most part, developers really doesn't get in the way of the developers. They continue to commit their code. They commit their code into a source code management system. We then typically pick it up in a CI system that runs the build, and then the build can decide whether to allow that to go be pushed into production. When we think about where to go deploy this software composition analysis, if you recall back to the complexities of package managers, etc., you will now understand, hopefully, that the only place where you can actually run this effectively is in continuous integration, because that is the only time when you run the build when you actually know what open source is being consumed. And so the first generation of these tools were really kind of grepped through source code, and essentially kind of try to figure out you're using this library and you may have some vulnerabilities here. That's unfortunately ineffective in this modern world of open source. And we also see that same thing. People are deploying containers, and those containers get built, and updated. So often one of the first things that a Docker container does essentially is run apt-get and updates itself, and then pulls its code in and runs the build. And so these CI systems are really becoming the authoritative place where we're assembling software in the code pipeline. But the great news about that is it also gives us the opportunity to make a set of security decisions inside of that pipeline before we push things out to production. So with that, I'm going to pause. We'll go to any questions, and then if we have time, we'll basically share my screen, and we'll log into SourceClear, and we'll go look at a couple of projects. So Amir, maybe I could over to you, and we could answer some questions.
Absolutely, Mark. I have a couple of questions here for you. Our first question would be, are you seeing any correlations between the adoption rate of DevOps within organization and their reporting and management of third-party and open source components?
Yeah, absolutely. So, I think that what we see with DevOps is an opportunity to retool. And so companies that are embracing DevOps are embracing that by new processes and new tooling. And part of that is embracing new ways of doing security. So for sure, companies that are advanced in DevOps, and this is a huge generalization, are rethinking security and putting things like software composition analysis and SAST into their pipelines and applying policies so that it makes it easy for developers to do the right thing. So I think there's certainly a correlation. Having said that, we have customers that frankly are still building in waterfall and doing things very well, and so it's not a given that if you embrace DevOps and you put security into the pipeline, everything happens. But there's certainly a correlation between those two. Sure.
Great, thank you. Next question we have for you, Mark, is what are some of the best practices development teams can take to begin taking in inventory of third-party and open source components?
Yeah, sure. So, I think one of the first best practices is that, I forget who created the phrase, but you can only manage what you measure or what you know about. So, one of the first things that most people do is figure out what open source are we actually using, and most people are pretty surprised, right? They assume that they're using some pieces of open source, but they don't know exactly how much. So, the first thing that you can do is hook the back of those package management systems and then figure out what you have in your inventory. And it's a great first step to get visibility into exactly how much open source you are using and where you're using it. The second kind of piece about doing that is that what you also know is exactly what you're using. So when new vulnerabilities come out, you're able to correlate that and go back and figure out, great, we are using this library and it's being used in this project. And so we can kind of show you some of that on the screen if people are interested. So hopefully you can see my screen. I've just logged in. I'm being a bit of a contortionist on my desk because I have my phone in my left hand and I'm keyboard on a laptop. So if I'm a little bit, but we have inside of my customer demo thing here, we have Apache struts and Spark and vote.gov, which is the thing that we talked about just now. And what you can see within those 50 projects, I'm actually using nearly 5,000 libraries. So let me just make that slightly larger. So you can see I'm using 5,000 libraries. If I selected here direct only, I'm including just over 1,000 libraries in my code. But when I go and run the build on those projects, it's almost 5,000 of those. And so having this inventory of these libraries is very useful for me to understand exactly what I'm using. Of those 5,000, of those 1,000 libraries that are actually included in my code, I can see here that nearly 900 of them are out of date. And so, in this particular case, the version that we had in here was this. The latest version that is available is this. And if we selected how many of those have vulnerabilities, I've now got 154 libraries that are in my code, out of date, and have vulnerabilities. So having that inventory of knowing exactly what we have and where we have it is incredibly useful. couple of weeks ago, there was a vulnerability, or months ago now, in the Apache Commons library. So I could then, if I see the news about that, I can say, great, show me how many Apache libraries. I'm using 330. Show me how many Apache Commons libraries I'm using. I'm using 61. How many Commons IO libraries? I'm not using any. So we're able to kind of filter down and understand from that inventory at any point in time exactly what's being used. In the early part, I also, we talked about the complexity, and I'm going to use the code for code.gov here because I think it's fascinating to actually understand. That thing that looks like the Starship Enterprise is the dependency graph for the code for vote.gov. And that in a ring are the libraries that the developer used. All of the other libraries are the libraries that then get pulled in by those libraries. And so in that particular case, I think the amount of libraries select on these, there's 19 that were used by the developer, 594 that were used. But that 594 is your inventory. Those are the libraries that your applications are using, whether you intentionally decided to do that or not. So having that inventory at any point in time is extremely important. Do we have another question there, Amir?
We have a couple more for you. Let's see. You didn't touch on open source licenses and how those can impact a product once one is creating. Any pointers on following up?
Yeah, for sure. So licensing is a complex subject for sure. We're a security company first and foremost, but I think licensing is kind of becoming an important thing as well. Each open source license itself has so each open source library typically has a license, but that is not true that everyone has a license. So let's go have a look at all the licenses that we have. So this is a list of all the licenses in those 4,938 libraries that are being used. And as we can see, there's no shortage of licenses here, but including projects that have no license specified, GPL, and some pretty obnoxious licenses that get included in a lot of people's code. What you're able to do is to pull the license from each of the libraries that get used. But there's a dirty little secret, and that dirty little secret we discovered around licensing is similar to the one with vulnerable libraries. So it turns out that the vast majority of time when you use vulnerable libraries, you don't actually use the vulnerable part of the vulnerable library. So for example, in this case, and we'll get back to why this is important from licenses in a second. In this case, I have 911 vulnerabilities, and this is of course my customer demo world, where we've identified libraries that are vulnerable. But it turns out we actually only have 23 instances where we're actually using the vulnerable part of the vulnerable code. That's our definition of what a real vulnerability is, and most of our customers will say the same. So in a DevOps world, I am using the vulnerable part of the vulnerable library, therefore I can't go to production, versus 911 times when I have a potential vulnerability. The same occurs in the licensing space, and it turns out that even if you are including a GPL library, the vast majority of times there is no call to that GPL library, therefore you are not invoking that copyleft clause. So licensing is absolutely important. I think it's rife for innovation, and the first generation of tools were really kind of grepping around and just saying, hey, you're using this license. But the reality is the same as the security problem. The majority of people are not actually affected by that. It's also interesting when you go look at GitHub. GitHub allows you to put a license file in the root of the project, but that license file isn't tied to the actual licenses of the individual libraries. So I forget which case it was. I think it was the one I always used to use was I think it was a project called Sales, which was a Node framework, and it claimed it had an MIT license, but actually if you go scanned it, it was using a whole bunch of GPL code. So it's a complex problem for sure. I think it's another one that is going to cause a lot of challenges moving down the road. Any other questions there, Amir?
I think we have one more. It's not necessarily a question, but more of a comment, and perhaps you can use your expertise to follow up with it. So A wise manager told me years ago that one should strive to reduce dependencies wherever possible. How do you feel about that one?
Well, so, I mean, I'm in two minds. So I've spent half of my life running engineering teams and half of my life as a security guy. So my perspective is conflicted, I guess. So I think it's certainly true when we think about the attack surface. From a security perspective, you think about the attack surface, like how do you reduce the attack surface? You reduce the number of libraries, and that absolutely makes perfect sense. And it's certainly true from a developer's perspective. You add libraries, but you very rarely take them away. And in fact, we've been doing some work in our R&D team here around, looking at projects and figuring out where you no longer make a call to libraries and what you can actually remove. And in general, that's not a development practice. You add libraries, but there's very little tooling that configures out, are you actually still using all of these libraries? But if you build code in like if you're building a React application, you add a React component, and you import it, and you're not calling the component. Like the linter just tells you, link is not being used. You don't need to call this thing. But we don't have that same notion in the security world. This library is not being used. Remove it from your project. So I think there's certainly truth to that. Having said that, I think that the philosophy that we come from at Veracode, and certainly I fundamentally believe in, is that open source is amazing. I've spent 20 years doing it. I met some of the most amazing people. I think it is fundamentally changing the world. Like I said, autonomous cars and Google and all of these things. So we shouldn't fear it. But what we do have to do is we have to think about the fact that there are new ways that we have to do in order to secure it. And so I think trying to avoid it is probably not the right approach. But what we should do is we should think carefully about what we're using and how we're using it and its quality. And again, ask those four questions. What do I have? Where did it come from? What does it do? And what's its security quality? And if you answer those four questions and you're able to satisfy yourself that this is code that I need, it's doing something which is good, I trust the person who created it, and it's not got any security vulnerabilities, then we should feel confident going ahead and using it. And I think that being able to answer those four questions and is a way to empower people to embrace open source in a way that's safe, ship fast, and go and innovate. So hopefully that answers that question.
All right. Well, thank you very much, Mark. We have currently run out of time, run out of questions as well. But with that, I would like to have a big thank you to Veracode for this presentation. Mark, our webinar speaker for today, thank you very much for your expertise and your knowledge in the subject. A big appreciation to IEEE Computer Society, as well as all of the individuals who have registered for this webinar and who are viewing it live. We do appreciate your participation. Have a great day.